Good day, class. Welcome to our CIE 318 lecture. So, like we started in the last class, we'll be looking at truss analysis using the methods of joint. So, we have this question before us that says determine the forces in each member of the roof truss shown in the photo. The dimensions and loadings are shown in the figure below. It says we should state whether the members are in tension or compression. So one thing we'll first do is to determine our reactions. Let's call this RA. Let's call this reaction RA and this RD. So from what we have learned earlier, we can simply determine this by, first of all, we can take moments about A. We will take moment about A, a moment about A, and if we say this is our positive direction, it means that will be 3 times 2, let me use this bracket, plus 2 times 6 plus 3 times 10 equal RD times 16. So if we do this, this is 6. So if you do that calculation, that will be your RD will be equal to 4 kilonewton. 4 kilonewton. Okay, so since it is symmetrical, since the structure is symmetrical, your RA is also 4 kilonewton. Although you could find RA by saying summation of moment, summation of Fy, forces in the vertical direction. That is, if we say this is positive, then Ra plus Rd equals to 3 plus 2 plus 3. Okay, that is 3 plus 2 plus 3, as Ra equals to 8 minus 4. Therefore, your Ra equals to 4 kilonewton. Okay, but if you want to avoid doing all this, just look at the structure is symmetrical. It means the other part is the same. So we have our Ra, and so if this is a pin connection, it means we have another force acting on the horizontal. So summation of forces in the horizontal direction Fx equals to 0. So if this is our positive, that means Rx will be equals to 0 because there is no other force acting in this direction. So we have that, and so we have it like this. So we can start from looking at this structure from joint A. We can start from joint A. We consider joint A, say considering joint A. This is joint A. Let's say joint A. So we see we have a 4 kilonewton force coming into the joint. Oh, sorry about that. we have a 4 kilonewton force coming into the joint. Okay, we have we can choose a direction for this. We say it's leaving, and for equilibrium we can say this is also coming into the joint. So whatever direction you pick, at the end of the day, what matters is if your if at the end of the day what you get is negative, it means the direction you picked was wrong. You just have to reverse the direction. It doesn't have to affect your answer. You just have to reverse the direction. If maybe at the end of the day what you get is negative, it means the one you picked as compression, that's going into the joint, will have to come out. You have to change the direction to be going out of the joint. So if we have this, we have this 4 kilonewton. We have this 4 kilonewton going into the joint as seen. Then we have this, we also assume is coming into the joint, and we assume that this is leaving the joint. So this is our is coming from A to G. So this is FAG. FAG. This is from A to B. This is force AB. Okay. So now we just apply our equilibrium equations, and we say summation of forces in the vertical direction equals to 0. So if we take this to be positive, I hope you know how to resolve forces into components. So let me just give you an example here. And this angle is 30 degrees. This angle is a 30-degree angle. So if we have this force and we are resolving it into components, it means this is horizontal, this is vertical, this is horizontal. Wherever this angle is facing is your sine, right? This is sine theta. It's not that it's vertical that is sine theta, it's where the angle is facing, and then whatever is remaining is cos theta. So now summation of angles to the vertical direction, if we say this is this, it means we have 4 minus FAG sine 30, which is equals to 0. Okay, if you solve this, FAG will be, you get FAG as 8 kilonewton. Since it is positive, and we are initially, let me write that well. Since it is positive and we initially assumed it to be in compression, it means FAG is in compression. If it was negative, that means we will now change the direction of FAG to go out of the of point A of the joint. So now taking now summation of forces in the horizontal direction, if we take this to be positive, it means that we have FAB, right, minus 8, because we have our FAG as 8 already, right, minus 8 cos 30. I didn't write that well. Let me. Hey, what did I just do? Oh, minus 8 cos 30. We jumped a slide. I just saw that. But no problem. We'll get to it. Minus 8 cos 30 equals to 0. Okay. So our FAB is still ends up being positive. FAB equals to 6.928 rather. 6.928 928 kilonewton. So initially we guessed it to be in tension. So this is tension. I hope you remember that we said that when the force tends to stretch the member, it means this is tension, right? This is tension. And when the force tends to reduce the member, like it's going into the member, this is compression. Okay, so whatever is coming into the joint, as it's we said this is coming into the joint, this is compression. If it's leaving the joint, it is tension. That's what we simply mean, right? Okay, I hope you remember that point. So I will erase that and we look at the next joint. We look at G. Joint G. We look at joint G. Where is this thing? So we go to joint G. If we take joint G for instance, joint G is like this. This is joint G. Okay, so this is joint G. There is a 3 kilonewton force acting on joint G, and we have our 8 kilonewton that we've just gotten coming as AG from this to this point, 8 kilonewton, and we have this force FFG coming, and then we have this force FGB. We have this force FGB. So this is our 3 kilonewton. This is 8 kilonewton. This is FGF, and this is FGB. The angle between these joints, like we are seeing here, let me use a laser pointer. The angle between this joint, like we are seeing here, which is in this place, is 60 degrees, right? So now, if we have observed, the inclination of this makes us to have our x-axis in this direction. Okay, this is our x-axis, and our y-axis, for it to be perpendicular to the x-axis, acts in this direction, right? Maybe I should use another color to draw the x and y axis. Eraser. Our x-axis lies in this direction, right? And our y-axis at perpendicular distance at the perpendicular lies in this direction. So if this angle is 60, let me draw this out as well. So if you notice, so if this angle is 60 degrees, then we have this angle. If you look at it, if I put if I draw this, if I come here, we have a 30 degrees angle here, alternate angles. This angle will be 30 degrees, right? So this angle is 30 degrees. Okay, so if that has been done, so this is joint G. That's joint G. So now, for us to avoid unnecessary simultaneous equations, we would follow the direction of the x and y axis. So if we say summation in the vertical direction equals to 0, because of the orientation of our x and y axis, our vertical direction becomes like this, right? If we say this is positive, hey, I'm even writing my plus in that direction. If we say this is positive, if we say this is positive, it means we have our FGB, our FGB in the this FGB, right? So if we take it like this, sorry, it should be coming into the angle. Okay, FGB, okay, yeah. So the angle is facing that, so it will be FGB, that will be sine FGB sine 60 minus, if you look at the vertical direction of this, so this is our y and this is our x, right? So this is facing the sine. Now it is the x-axis that is the sine, because that's where the angle is going. So our y-axis then becomes cos. So minus 3 cos 30 degrees equals to 0. Okay, so solving this, we have our FGB to be equal to 3 kilonewton. So since it is positive, our FGB initially we took it to be in compression, so compression. So summation of forces in the x direction, in the that's horizontal direction, equals to 0. So we follow suit, and this is positive. So it will now be 8 kilonewtons, because 8 kilonewtons in that direction already, 8 kilonewton minus 3 sine 30, because you know this is the sine angle is facing the horizontal, is towards the horizontal. So minus 3 sine 30 degrees minus the value of FGB minus 3 cos 60. The 3 is the new value of FGB minus our FGF. Our FGF we don't need to resolve it because it's already in that direction, minus FGF equals to 0. So solving this, our FGF becomes 5 kilonewton in compression. Okay, so that's that, and we move to the next joint, joint B. Joint B. So let's take a look at joint B. Let me see. Okay, I noticed, so I'll be flipping backwards because I noticed that we jumped a particular side that I would have used for joint A instead. So let's use this for joint B. So joint B now. So for joint B, where is my pen? Okay. So for joint B, we have joint B. This is joint B. So we have joint B, we have this force acting on joint B, we have this force acting on joint B, okay? And we have FBF coming towards this, and we have our FGB on joint B. So for equilibrium, we assume this is coming out and this is coming out. We could assume any direction, but just notice that, just know at the back of your mind that if the direction you assume end up giving you a negative answer, it means the direction is wrong, and so you have to change your direction. You don't have to resolve again, but just change your direction, okay? Just change the direction. So, and then this is our XY plane. This is our XY plane. This is our X. This is our Y. Okay. So we have FBF. We have FBF. We have FBC, and we have B. We have this angle. This angle. Let me use a laser pointer. This angle is 60 degrees. That's this angle, 60 degrees. This angle is 30 degrees. That's this angle, 30 degrees. Okay? This FBF, FBF, FBF. This is FBC, FBC, FBC. This is FGB. This is FGB, and this is FBA, AAB, FAB. Okay? Which we have already gotten values for in the in when we consider joint A. So going back, we have this as 6 point. Why am I making a mistake? So pen, we have this as 6.928 kilonewton. We have this as 3 kilonewton. So this is joint B, right? So still the same, summation of forces in the vertical direction, Fy equals to 0. We have FBF sine 60 minus 3 sine 30 degrees equals to 0. I hope you are following. Okay, this is 60 degrees. This is 30 degrees. I hope you are following. If we resolve this angle, okay, if we resolve these angles, FBF and this, okay. So since FBF, this is the angle, this is where it is facing. This is FBF sine theta, sine 60 cos 60, okay. Remember what I said, that it is where the angle is facing that takes sine. whether it's facing the horizontal or vertical, wherever the angle is facing, that's where sine is. The other angle is cos. Okay, so FBF becomes 1.73 kilonewton, and that is tension, which is the direction we picked. So summation in the x-axis equals to 0. In the x-axis here is horizontal. So if we take this as our positive, we have this. We have our FBC plus 1.73 cos 60. Okay, you know, our FBC is 1.73 cos 60 plus 3 cos 60, 3 cos, sorry, cos 30, cos 30 okay, yeah, minus, let me write it down here, minus 6.928 equals to 0. Solving this, we have our FBC to be equals to 3.6, 3.4, let me just, 3.46 kilonewton, and it is in tension. Okay, so with that, we have given the, so we don't need to go ahead to solve this other side of the truss. If you notice, this truss is symmetrical. What is happening here is what is happening here. So whatever forces we have on this side of the truss is what we have on this side of the truss. So as it is, we are done with our solution. So we'll stop here, and please, if you have any questions, you can always meet me to ask. I had to do this because we've been having venue issues and the time issues to meet. So this is another way we can do this. So please go through the video, go through it, understand it. If you have any question, you can always ask me. Thank you.